Hello everybody. We're going to be talking about the exponent operation. Before we get to the exponent operation, let's go all the way back to kindergarten and start off with that. So in kindergarten you learned how to count, and counting was just repeatedly adding on 1 from 0. So you got something like this, and you were told to how many things is this? So this is our unit, so we say 1, 2, 3, 4, 5. There's 5 things here, and this is counting. This is repeatedly adding 1. So example would be like you're given a bunch of things, some ones. These are just like units, and then you say that they are equivalent to this symbol, this Arabic symbol, 5. And you had to memorize all these symbols from 0, 1, 2, 3, on to 9. And then you learned about placeholders and place value, so that when you got to 9, the next thing you went over and you said this is 1, 0 or 10. And this is how counting works, right? So the notation now that we're going to use in algebra is that there are these placeholders like x or a or something like that, and they can represent any of these numbers that exist in the counting world. Okay, so you learned how to count up things. The next thing you learned how to do was to add. And add is just to repeatedly count on, right? So you take this counting idea of repeatedly adding 1, and instead we want to start at a different spot. So we say, okay, we're going to start with 3 and add 2. So we're going to repeatedly add on those 2. So you say 3 plus 2 is the same thing as 3 plus 1 plus 1. And that's equal to 5. Or you could start at another spot. You could say, well, I want to do 2 plus 3. 2 plus 3 would be, let's start with 2 and then repeatedly add on. And you saw that you get the same answer either way. If you counted 3 up 2 more, or you start with 2 and counted up 3 more, you get the same answer of 5. So that's how adding works. It's repeatedly counting. And now our notation for this would be just the plus symbol between 2 things. Okay, multiplying. Now multiplying is just repeated adding, and that's probably the first way that you learned it and may have forgot about it, but that's what multiplying is. It's just repeatedly adding the same number that many times. So if you had 2 times 3, it would say it's the same thing as repeatedly adding 2 3 times. This is 2 plus 2 plus, now if you get another cube, plus 2 is 6. And it's also could be written the other way. 2 times, or 3 times 2 is repeatedly adding 3 2 times, and then you probably found out at some point that you got the same answer. When you took 3 and added it twice, you also got 6. And you probably found out that it has this area idea, that if you have 2 things grouped this way 3 times, or if you have 3 things grouped 2 times, that either way you would always get the same answer. So notation kind of changes with this from time to time, and they don't like to use, after you get out of elementary school, they don't like to use this x symbol as times anymore. So it could be written as x dot y, or sometimes they leave it out altogether and they just bunch them together, or sometimes they use parentheses. So there's a lot of different ways to write it, but that's one of the kind of hard things about is just understanding the notation. That all these things are represent multiplication. Okay, and by the way, if we had 2x, for example, that is this notation. It's just the number up against the variable or placeholder, and that just means, what does that mean actually? If I wanted to turn this into a plus problem or an addition problem, it'd be 2 times x, so it'd be I can say it's 2 plus 2 plus 2 x times, right? And I don't know how many that is. Or I could say, well, it's x plus x, right? X 2 times, right? Like if I switch the order, it's x 2 times. Okay, so that's 2 ways to think about it. All right, now what we're getting to now is the exponent operation. Exponentiating is just repeatedly multiplying. So you see how this builds up. From adding is just repeatedly counting on. Multiplying is just repeated adding. And now exponentiating is just repeated multiplying. So we have something like 2 cubed, and we say we have 2 special ones. There are 2 special names that are within exponentiating. They're the squared and cubed, because they have a unique use in geometry, right? Because squares, you take one side times the other side, and it's the same thing times itself. So we have this side's x and this side's x. It's x times x, or we call it x squared. And then also cubed has a unique thing in geometry where you have a cube that has all the same sides. So x, x, and x. You do x times x times x to get the volume of something, and that's x cubed. So this 2 cubed just means 2 times itself 3 times, and if you want to see how that works, you have a cube like this, and it's 2 times 2 times 2. So you have 2 times 2 is 4, and then 4 times 2 is 8, right? So this would be 2 times 2 times 2, which is 8. And it doesn't actually work in reverse, though, like the other ones do. 3 squared is 3 times 3, which is 9, right? So this is a square, right, of 3 times 3. Looks something like this. And we get 9. Okay, so the notation for this would just be x to the y. And with this y part means how many times you're going to multiply it times itself. So it's x times x times x, y times. So the final part of this notation is that you can write, this is called the base. Just like with addition, you have this is like the add-in and addinuum or something. And this is the exponent. And together we call this the power. The whole thing together we call it just the power. So the base tells you what number you're multiplying times itself. The exponent tells you how many times you're going to multiply it times itself. And the power is kind of just the base with the exponent together. Okay.